I'm here at the Royal Economic Society's annual conference here at the University of Bristol. I'm talking to Igor Kheifets, who's the winner of this year's Denis Sargan Prize, which is for econometrics. Igor, thanks for being here.
Thank you for inviting.
So your paper is about dynamic nonlinear models. Could you just explain what they are?
Okay, so let's think about exchange rates, changes in the exchange rates. You can think about British pound against euro, British pound against Swiss franc, or maybe you consider Mexican pesos and American dollars, okay? So the simplest model for this would be that your data is independent and normally distributed. So alternative to that would be some nonlinear model and some dynamic model. So, for example, this fall there were elections in the US. So before elections and after the elections, after Trump won the US elections, the exchange rate changed its behavior. If we talk about Mexican peso and the American dollar, okay? So this change in the behavior, we call it nonlinear change. Other example, you can think about macroeconomic variables. So when you're in a recession and when the economy is growing, you have different factors affecting macroeconomic variables. Another important feature is dynamics of the model. Okay, so maybe ID assumptions. The assumption that your data is coming independently from the past is not true.
So maybe the change today is actually dependent on the change yesterday or the change before?
Almost correct. So typically we think about exchange rates, changes. So if you look at changes, there is very little predictability. That's because a lot of people can trade. So it's very difficult to predict what is the exchange rate tomorrow or the change of the exchange rate. What is typically possible to predict is the volatility of exchange rates. And volatility tomorrow depends a lot on volatility today. So for example, we expect tomorrow a high volatility if today we have a high volatility. So this time dependence introduces dynamics into our models.
The challenge that your paper addresses is how to test whether your model of this, process is correct, right? So you think that you know how the exchange rate system works or how the data is changing over time, but you need a test for whether you've got that right.
Exactly.
So how do you go about doing that?
There are different ways to test models, and the big problem in testing is that you don't know against what alternative do you test. Okay, so you assume something very simple. Maybe you assume that your model is independent and normal, and the truth, who knows where is the truth? So you want to catch the truth. So and the big problem in specification testing is that you want to be able to test or to catch all possible alternatives. That's a big problem of testing.
And are there lots of ways of doing this, or is it a relatively unexplored area?
There are a lot of papers trying to deal with it, and typically what people do, they say, we think that maybe the truth model deviates from your hypothetical model in some certain way. So for example, you may assume that your model is normal, but you can test it against fat tails. Okay, so fat tail is a very important phenomenon. It says that the probability that you lose a lot of money is actually much higher than your model predicts. So if you want to test against this specific feature of your model, then you can do this. And there are many models which attempt to do this. Now what I'm proposing, I'm trying to make a test which can capture all kinds of alternatives.
So the dynamic nonlinear models, there are already tests for those that you've got the specification for those models right. And so you're providing a new kind of test.
So my test can capture a wider set of alternatives. So my tests can test simultaneously for nonlinear departures and for dynamic departures from the hypothetical model.
So we've mentioned exchange rates and macroeconomic variables. Are there any other areas where this test is going to be really useful?
So for example, the benchmark model I was talking about, normal and ID data, this is the model also for stock returns. Okay, so if you want to model stock returns, maybe you also, for simplicity, want to assume normality and independence. You want to be sure that you're not far from this assumption. So you want to keep testing all the time this kind of model. For example, if you want to describe change in volatility, Okay, you also want to test this kind of models.
So which types of models can your test be used for?
Oh, there are many models which you need to test using my procedure. For example, Tim Boroslev has a paper of 40 pages which has a set of volatility models. So it's basically a glossary of models. So every page has like 5 models and 40 pages. So it's like, what, 200 models? So most of those models you can test using my methodology. So apart of financial econometrics, you can use also macroeconomic models. So where you have time series and nonlinear dependence of macroeconomic variables.
So should financial traders use your model to make a killing on the stock market?
Definitely.
Well, thank you very much.
Thank you.